Hey guys, how are you doing? This is something a little different here, obviously. Usually don't see me, but what I did is I hopped on Zoom so that I could do a screen share. And so after doing the last video, I actually typed in Riemann Sum Calculator, and I found that they actually have one on Desmos. And so I thought I would share that with you. So let me do a screen share here. See if I can um, so let's see if I can, okay. Hopefully I'm sharing this here. I'm going to Google. I'm going to type in Riemann Sum Calculator. And you're probably going to get all kinds of things. You could look at some other things, but I thought I would show you the one on Desmos. So it's like the third one down when I typed it into Google. And so, okay, this is just really weird. It took me a moment to figure out how this works. But what I'm going to do is let's go ahead and use the function that we were using before, x squared. So I'm going to do x squared. And so I'm going to type that in. And now I want to get a nice, from 1 to 3 here. There we go. Maybe even zoom it out just a little more so I get to where 3 crosses the axis. Okay. There we go. So these are going up by 2, so 3 is right there, and there's 9. And so I'm going to do the area. I want to do the area from 1 to 3. So what I'm going to do is this is the left point of my interval. Okay, so I'm going to make that 1 because that's what we were using. And then the right end point is going to be 3, which it is already. And so this is going to be the number of intervals. So let's do what we did before where we use 4 sub-intervals. And so I do put that to 4. So this is my left endpoint, right endpoint of the interval, number of intervals. And then it says you're going to choose c equals 0 for a left-hand sum. So this would be a left-hand sum. C equals 1 for a right-hand sum. And then c equals 0 for a midpoint. I'm sorry, z equals 0.5 for a midpoint. Okay, so let me just do the left-hand sum. So here it's the left endpoint for each of these intervals, right? Creating the height of each rectangle. And this is the formula here. And you can see I get 6.75, just like I did before. Okay, now if I change this to a right endpoint sum by switching the c to 1, there's my right endpoint sum, and I get 10.75. Isn't that neat? And then it'll even do the midpoint. So you just click this and go to 0.5. And then it's taking the midpoint of each interval, right? And then there's the answer, 8.625. And these are exactly what I got when I did them by hand. So that is so neat. I think that is really neat. And here's the really amazing thing. So let's say I want to do 8. We'll do 8 rectangles. Well, I can do that. Now it's split it up. So now the width of each of these rectangles, instead of being 0.5, is half of that, 0.25. And we now have 8 rectangles. And for the left-hand sum, which is the underestimate, I get like 7.687. For my right-hand sum, the overestimate, I get 9.687. And then for my midpoint, I get 8.65625. That's my midpoint estimate. So you get your left hand, right hand, midpoint estimates just like that. That's 8 rectangles. You could go to 16 if you wanted to, and it just does it all that fast. So neat. If you're someone who's kind of was right before the technology when you were in college, and you did all this by hand. It's just amazing how fast this can do it. So here's the midpoint rule. This is actually very close. The actual answer is 8 and 2/3. So it's like 8.6 repeating. So that midpoint rule with 16 rectangles comes really close. Okay, and it's even converging pretty good with left hand endpoint. So 8.17, right hand 9.17. Okay, so, and you could do all the way up to like 100 rectangles, and 100 you can barely see. So my left hand sum is still not, it still doesn't have, it's the actual answer is 8.6 repeating. So even with 100 rectangles, it doesn't even get the tenths place right. It's close. So that midpoint rule does pretty good. And this is 8.7. So again, neither of those get it even to the nearest 10. That's 100 rectangles. Wow. I would have thought it would have got closer than that. But this gets it to many decimal places. So that midpoint rule for this particular function works really, really well. And different functions, it depends on the curvature of the function, how well it's going to be. Different functions have different amounts of error. And so this would be a fun thing to play with here. Let's see, I could do, I could do like sine x. And maybe I want to do that I want to get the area of under one of those humps, I guess. Oop. Now here's the one drawback about this. Unless I can change, oh, I can. Oh, good. Let's just do pi. There we go. And I'm just going to bring that all the way to pi, I guess. But it's just showing the tenths place. So it's not quite pi. It must just get it to the tenths place. Okay, and then, I could do 8, 10 rectangles or something. And that's a midpoint one. So like 2.0, whatever. And I think the actual answer is 2. So that would be the left point sum. And look, as you're going up, it's an underestimate, but then as you go down, it's an overestimate. This is the left-hand sum. This would be the right-hand sum, and that would be the midpoint rule. And now I don't even know what these mean. That's kind of weird. It's doing something different, okay? But you really, for this one, you just use 0, 1, 2, or 0, 1, and 0.5. And those, I'm not sure what the thing, I'd have to sit and think about what that's doing in this formula. But you can see, you can put in your function, pick your endpoints, and number of rectangles. So you might want to even use this on the homework. I'd do maybe 1 or 2 by hand. But normally, a lot of this stuff anymore, people use technology. You want to be able to understand what it is you're doing. Okay. So that's important. You want to understand what you're doing, but then also being able to use technology is helpful too, because you save time and you can do more. And the pictures, look at that. I haven't even combed my hair yet today. Okay. So the pictures and visual interactions with the stuff actually does help deepen your understanding, I think, of things. So it's really nice, but you want to use it hand in hand, just not as a tool to quickly hurry up and get things done and jump through hoops, but use it as a tool, and it can be very valuable. So let's see. How do I leave? There we go. See you guys later. Bye.